Outline, introduction, network layer protocols, unicast routing, multicast routing, and next generation IP. We first discuss service, discuss about network layer IP at TCP/IP suite, about IP version 4 and ICMP version 4. We also discussed IPv4 addressing and rewrite issue. Concentrate on unicast routing and unicast routing protocols. Move to the multicasting routing protocol. Finally, discuss about new generation of routing protocol. Networking layer protocols. This section will show how the network layer is implemented in the TCP protocol suite. The protocols in the network layer have gone through several versions in this section. We concentrate on the current version 4. In the last section of this chapter, we will discuss version 6, which is on the horizon of the IP and other network layer protocol. It's TCP/IP protocols. Version 4, packet sizing, packetizing, forwarding, delivery of packets, a base of a stability service, unreliable collect bridge diagram protocol for packet switch network, base of a corrupted, lost, or write out of order or delay and may create a congestion for network. ICMP reinforced help IPv4 to handle some error. And IGP is an Internet Group Management Protocol held in multicasting ARP, mapping a network address to link layer address. This is upper network layer have transport and application, and under is a data link physical. We use IP to the packet of the network layer. IP version 4 datagram format. Packets used by the IP are called datagrams. In figure 4.224 show the IP version 4 datagram format. It's a variable range packet consisting of the two parts, header and payload. The header is 20 to 60 bytes in the range and contains of information essential to routing and delivery. It is customary in TCP/IP to show the header in 4 bytes second. Fragmentation. Maximum time for units relate to fragmentation. Security of IP4 datagram. Have packet sniffing, packet modification, and IP spoofing, IPsec. This is a IP datagram. You can see the header 20 to 60 bytes, and other is the payload. This is the multiplexing. The multiplexing uses a value of the protocol field. MTU, maximum transfer unit. The fragment MTU for LAN is 1,500 bytes. Each router encapsulates the IP datagrams, process it, and then encapsulation in the another frame, format and size of the received frame, format and size of the sent frame, is connecting a LAN to one. Each link layer protocol have all frame formats of one of the The feature of each format is the maximum size of the payload that can be encapsulated. The total size of the datagram must be less than this maximum size imposed by the hardware and software. Fragmentation example. So about this fragmentation, affirmant datagrams change the three value of T field, fetch and fragmentation offset and total length. The value of checksum recalculated regardless of the fragmentation. Fragmentation of offset field. The relative position of this fragment with respect to whole datagram. That the offsets of the data in the original datagram measured in units of the byte. Detailed about the fetch. If you have a 3-bit, third bit, the first bit is a leftmost bit not used. A second, if one not fragment, if can't pass and discuss it, if 0 can be fragmented. And the third bit called more fragment bit if one done the last fragment. If 0, the last are only fragment. About address. In the file, use the IP layer of TCP/IP precursor to identify the connection of each device to the internet. Is called the internet address or IP address. And IP version 4 address is a 32-bit address and generally and universally defined to connection of a host or a router to internet. The IP address is the address of the connection, not a host or the router, because if the device is moved to another network, the IP address may be changed. Address space is 32 bits. Notation hierarchical in the addressing class full address. They have a profit link extracting information from the address mask, network address block, subnetting address, aggregation special address, dynamic host, configuration protocol, NAT. Two different notation in IPv4 addressing. One is binary or dot decimal, hexadecimal, decimal. Hierarchy in addressing have the prefix can fixed length or bank length and fixed length so the class. This is to tell you what is the class of this in prefix. Define its work and define the connection to the node. Augmentation of this other aspect in careful address. And slash notation. Information extraction to the classes address. It's an example for for network layer. This is example 4.1. The cassette address is given 167.99.170.82/27. Number of addresses in the network is 2 power 32 is equal 32 address. The first address found by keeping first 27 bits and sharing the rest of the zeros. The last can be defined keep the first 27 bits and sharing of the rest of the bits to ones. Repair. Example 4.1 using the mask in dot document notation is 256.256.256 dot 224 and the and out and not operation can be applied to individual byte using calculators and a printed book website. Network address. So this is example 4x5 and it is a solution of this problem. Solution to example 4.5. I can't expand it because it's so hard to expand. Look at the picture. Figure 4.37 shows how 4 small blocks of address are assigned to the 4 organized by SISP. The ISPs combined these 4 blocks into one single block and advertised the larger box to the rest of the world, and packet designed for this larger box should be sent to this ISP. This is the responsibility of this ISP to forward the packet to the proprietary organization. This is similar to routing. We can find a postal network of packets coming from a country send referred to capital and then distribute to a corresponding destination. Example of address aggregation. Summary. The internet made of many network or link connected to connecting device, each of which acts as a router or as a switch. Two types of switching are traditionally used in the networking: a circuit switch and a packet switch. The network layer is designed as a packet switch network. The network layer supervises the handling of packets by the underlying physical network. Delivery of the packets can be direct or indirect to categories of forward defined forwarding based on destination area of this IP/TCP protocol and forwarding based on the label akin to an IP. IP version 4 is an unreliable connection rest protocol responsible for source to destination delivery packets in the IP layer and cloud datagram. The identifier used in the IP layer of the TCP/IP protocol suite are called IP address, and IP version 4 address is 32 bits long, divided into two parts. The one is prefix and the top suffix. Address in the block have the same prefix. Each address have a different